Section 3.3 really just continues what we were doing in section 3.2. Now, I mentioned this very interesting idea that we had these x cubed equations and we're getting 3 answers at the end. Do you remember that? I talked about the fact that that is not a coincidence, and so we're going to see that come back to play here as well. Before we do, let me actually mention what's called the roots and multiplicities property. It talks about the fact that if you have a factor x minus c and there's multiple factors, then that corresponds to multiple roots. In other words, if I had an x minus 2 listed twice like this, it was squared, then that would mean I had an x minus 2 twice. And if I set each one of them equal to 0, I would get 2 2's, right? These 2 correspond to the power 2 here. That's all this says, is that the powers correspond to the multiplicity of the roots. So we can't duplicate or triple or quadruple the number of roots that we have. It's just based on the powers that we get. With that in mind, we're going to do an example, a little bit more complicated than x squared, or x minus 2 squared. But it has these powers involved. So you see a power of 3, you see a power of 2, and there's no number here, so it's an understood 1, there's a power of 1. So what it means is that if I were to do this same sort of thing, I would duplicate or triple or quadruple or whatever my roots. So over here I have x cubed equals 0, and when I cube root, my x will equal 0, but there's 3 of them, so we say it has a multiplicity of 3. There's 3 zeros actually, 3 times when x is equal to 0. If I do the same thing on the next one, x minus 2 squared equals 0, and I square root, I get x minus 2 equals 0, I add my 2, x will equal 2, but what will its multiplicity be? It's based on the power. What was the power? 2. The power up here was a 2, right? So there are 2 times when x is equal to 2, because it's x minus 2 squared. And then the last one is x plus, was it plus? Yeah, x plus 4. I will subtract my 4. X is equal to 4. And what's its multiplicity? 1, because it's only got a power of 1. That's fabulous when it's already in factored form. Let me talk about what happens on B when it's not in factored form. First of all, please don't freak out just because you see things that have powers of 5. What that means is that you need to see if there might be the ability to simplify any of it. So notice that there's a factor in common to all of these. What is it? It's x. How many x's? 3. I can take an x cubed out, and if I do, I have x squared minus 6x plus 9, taking x cubed out of each term. So I know you guys are real tempted to go, but this clock is actually fast, just so you know. X cubed. X squared minus 6x plus 9 factors, both x's. This says my signs match. This says they're negative. I need 2 numbers that multiply to 9 and add to negative 6. Negative 3 and negative 3. Now, you don't necessarily have to write this out as x minus 3 squared. You can if you want, or you can simply recognize that there are 2 of them here. If you set x cubed equal to 0 and you cube root like we did before, you find that x equals 0 with what multiplicity? 3. And then over here, if I set x minus 3 equal to 0, x is equal to 3, what's its multiplicity? 2. Its multiplicity is 2. Okay? So really, the only new thing about this that I just showed you is writing the multiplicity, and it's based on the power that's there. We'll pick back up in the middle of 3.3 next time.